Dear students, hope that you are all doing well. Today we are going to learn multiplication of rational numbers. This is my second class in this series. You remember in my last class we learned about the addition of rational numbers. Before we go further, I just want to remind you all what we have learned in the last class. In the last class, we learned closure property for addition, number 2, commutative property for addition, associative property for addition, then additive identity, and finally additive inverse. What we are going to learn today is the multiplication of rational numbers. First of all, we're going to learn the closure property for multiplication. Okay, let me explain this property. If P by Q and R by S are two rational numbers, then their product, which is P by Q into R by S, will also be a rational number. This is what is called the closure property. Let me explain once more. If P by Q and R by S are two rational numbers, then their product, which is P by Q into R by S, will also be a rational number. This is exactly what closure property is. So, let's verify this fact by the following examples. Let's multiply minus 2 by 7 and 3 by 8. Let's do that. So minus 2 by 7, the sign of minus 2 by 7 is minus. Alright, and the sign of 3 by 8 is plus. We know that minus into plus is minus. Now, in order to multiply two fractions, we'll multiply the numerators. That will be the numerator of the answer, and then we will multiply the denominators. Here the denominators are 7 and 8. So let's do. So the numerator, we have already multiplied the numerators. The sign. So which is minus. Then we'll multiply the numerators. So 2 3s are 6. Okay, numerator of the answer is 6, and then denominators are 7 and 8. So their product is 7 8s are 56. So while multiplying minus 2 by 7 and 3 by 8, we are getting minus 6 by 56. Listen, you can simplify it. Even in the here in LHS itself, you can simplify. Let's simplify it. 56, 6 and 56. Both are having the common factor 2. So while cancelling with 2, the denominator will be 3. It is 28. So the final answer will be minus 3 by 28. Now look at minus 3 by 28. Minus 3 by 28, which is a rational number because it is in the form of P by Q. P means the numerator, which is minus 3, and the denominator is 28. You remember the definition of rational number? So a rational number is a number having a numerator which is P and the denominator Q, and the denominator should not be equal to 0. Such a number is called a rational number. In this case, here the numerator is minus 3 and the denominator is 28, and 28 is not equal to 0. So this is a rational number. Now let's learn one more example. So here we have to multiply 2 by 3 into minus 18 by 25. Let's multiply. Here 2 by 3 is an improper fraction. So before we multiply, improper fraction has to be converted into proper one. So let's convert it. 1 3s are 3, 3 plus 2 5, So 5 by 3 into minus 18 by 25. Let us try to simplify it right to here. 3 and 18 can be cancelled by 3. So 1 3s are 3 and 6 3s are 18. Again 5 and 25. 5 5s are 25. So the final answer is minus 6 by 5. Okay. Now look at minus 6 by 5, which is also a rational number. Okay. So what is the conclusion? This is a conclusion. You take any two rational numbers, multiply it, then the result and the product will also be a rational number. So we can say that multiplication of rational numbers is closed. Now we are going to learn commutative property of multiplication. You remember in my last class I taught you commutative property for addition. So here we are going to learn commutative property for multiplication. So let me explain it first. For any two rational numbers P by Q and R by S, we can write it like this: P by Q into R by S. It is equal to R by S into P by Q. So this is what is called a commutative property. That means two rational numbers can be multiplied in any order. Two rational numbers can be multiplied in any order. The result will be the same. So what's commutative property? That means P by Q into R by S is equal to R by S into P by Q. That means two rational numbers we can multiply in any order. The result will be the same. So let's go to learn this property with the help of a few examples. See here, what I'm going to do is I'm going to multiply 1 by 5 into 1 by 2, right? So this is a 1 by 5 into 1 by 2. These are two fractions. To multiply two fractions, we'll multiply the numerators. That will be the numerator of the answer. And then we'll multiply the denominators. That will be the denominator of the answer. So 1 1s are 1, 5 2s are 10. So this is the product of these two rational numbers. Now we are going to multiply 1 by 5 and 1 by 2, changing the order. So now this time I multiply 1 by 2 into 1 by 5. So that is equal to 1 1s are 1 and 5 2s are 10. What's the answer in this case? 1 by 10. In both cases we are getting 1 by 10, 1 by 10. What's the conclusion? The result will be the same even if we change the order. This is what is called a commutative property. We'll learn commutative property with the help of another example. Okay, here we are going to multiply two fractions. First one is minus 5 by 7 into second one is minus 4 by 7. We have to multiply these two fractions. So what to do? We'll multiply the signs first. So sign of the first fraction is minus 7. Sign of the second fraction is minus 7. So minus into minus is equal to plus. And then before we multiply the numerators and denominators, let's see we can cancel any number. So here 7 7 5 4, you cannot cancel. So the answer will be the product of the numerators and denominators separately. So 5 4s are 20 divided by 7 7s are 49. So this is the product of minus 5 by 7 and minus 4 by 7. Let's multiply it changing the order. So okay, this time minus 4 by 7 will come first. Let it be in brackets into minus 5 by 7. Okay, so let's take the product. Minus into minus plus. 5 4s are 20 and 7 7s are 49. Let's look at the result. First case it was 20 by 49. Even in the second case the result is 20 by 49. So what's the conclusion? That means two rational numbers can be multiplied in any order. That means P by Q into R by S is equal to R by S into P by Q. Now we are going to learn associative property of multiplication. You remember we learned the associative property for addition. Now we are going to learn the associative property for multiplication. So let me explain this property first. This is it. For any three rational numbers, P by Q, R by S and U by V, P by Q into R by S into U by V is equal to P by Q into R by S into U by V. This is P by Q into R by S into U by V. It is equal to P by Q into R by S into U by V. So what does it mean? It means that three rational numbers can be multiplied in any order. Look at LHS here. It is will multiply R by S into U by V first, and the result will be multiplied with the P by Q. We'll get a result. Again, we'll multiply P by Q and R by S. The result will be multiplied with the U by V. In both cases, the result will be the same. This is what is called associative property. It simply means you can multiply three rational numbers in any order. Alright? Result will be the same. Okay? Let's learn it with the help of few examples. Okay. Look here. So here I'm going to multiply three rational numbers. What are they? 3 by 7 into minus 1 by 7 into 7 by 8. Okay? So in order to multiply these three rational numbers, what I'm going to do is I'm going to multiply first and second together first. Okay? You can multiply second and third. Alright, I'm multiplying here first and second. Alright, that is why this is put in brackets. Okay, so 3 by 7 into minus 1 by 7. Let's multiply it. Look here, 3 by 7 is positive, minus 1 by 7 it is negative. So what is the sign? Plus into minus is minus, right? Now let's multiply the numerators. There is nothing to cancel, so 1 into 3, 3 divided by 7 sevens are 49, right? This is to be multiplied with 7 by 8. Okay, so here we can do a little bit cancellation. This is 7, so 7 sevens are 49, nothing more to cancel. So let's write the final answer, minus 3 by 56. Now this is the final answer, minus 3 by 56. Now we'll multiply these three rational numbers changing the order. Okay, so that is 3 by 7 into, alright, now in brackets, minus 1 by 7 into 7 by 8. Okay, so we'll write the first rational number as it is. Now we'll do the multiplication here. That is 7 can be cancelled. So this is minus 1 by 8. Okay, so that is 3 into minus 1, that is minus 3 by 7 8s are 56. Look at the result. So even in the first case we got minus 3 by 56. Even the second case we got 3 by 56. What is the conclusion? This is the conclusion. The result is the same, minus 3 by 56. Even the second case minus 3 by 56. What does it mean? Means three rational numbers can be multiplied in any order. Result will be the same. This is what is called associative property of multiplication. Next, we are going to learn multiplicative identity. You remember we learned in our last class, additive identity. What is additive identity? additive identity is 0, right? Now we are going to learn multiplicative identity, alright? Okay. So let's consider the following examples. Okay, the first one I have written 1 by 7 into 1, which is equal to 1 into 1 by 7. Why? So according to commutative property of multiplication. According to commutative property, two rational numbers can be multiplied in any order. So 1 by 7 into 1 is same as 1 into 1 by 7. You know that when you multiply any number with 1, the result will be the number itself. Therefore, 1 by 7 into 1 is equal to 1 into 1 by 7, which is equal to 1 by 7. Again, minus, this is the second example, minus 11 by 15 into 1 is equal to 1 into minus 11 by 15. This is equal to minus 11 by 15. So, what do we learn here? That means if you multiply any number with 1, the result is the number itself. That means 1 is the multiplicative identity. So, the additive identity is 0. When you add any number with 0, the result is the number itself. In the same way here, when you multiply any number with 1, the result is the number itself. So, what is the conclusion? 1 is the multiplicative identity. So, now let us generalize the fact. Okay? From the above example, we can conclude that for any rational number p by q into 1 is equal to 1 into p by q, which is equal to p by q. That means 1 is the multiplicative identity. Okay? Now we are going to learn the multiplicative inverse. You remember we learned in the previous class about the additive inverse. Okay? Additive identity is 0, additive inverse. For example, for the number 2. What is this additive inverse? Additive inverse of 2 is nothing but minus 2, because 2 plus minus 2 is equal to 0. So in the same way, we are going to learn multiplicative inverse. Okay. So let's consider the following examples. Okay. First one is 2 by 3 into 3 by 2 is equal to 1. When you multiply 2 by 3 and 3 by 2, will get the result 1. What is 1? 1 is the multiplicative identity. Right? Then second example is minus 2 by 7 into minus 7 by 2. Alright. So here the result is also 1. Why? Because you can cancel 7 and 7. 2 and 2, minus into minus is plus. That is equal to 1. Now next, let's see another example. Minus 11 by 15 into minus 15 by 11. Okay. Minus into minus is plus. 15, 15, 1, 1, 11 and 11, 1. So, in these three cases, we are getting the result 1. 1 is nothing but the multiplicative identity. So, what is the conclusion? Conclusion is, here 3 by 2 is the multiplicative inverse of 2 by 3. In the same way, 2 by 3 is the multiplicative inverse of 3 by 2. Secondly, here minus 2 by 7 into minus 7 by 2 is 1. That means minus 7 by 2 is the multiplicative inverse of minus 2 by 7. In case number 3, minus 11 by 15 is the multiplicative inverse of minus 15 by 11. So multiplicative inverse is also called a reciprocal. Okay. Now let us generalize the fact. For any rational number p by q into q by p, it is equal to 1. Okay. Let me repeat once more. For any rational number p by q into q by p, it is equal to, that means p by q and q by p are multiplicative inverse of each other. That means P by Q and Q by P are multiplicative inverse of each other. Multiplicative inverse is also called a reciprocal. So in order to find the multiplicative inverse of any rational number, what you have to do is just inverse. Change the numerator and the denominator. That's all. So let's summarize all what we have learned today. So we were learning the properties of multiplication for rational numbers. We learned first closure property, right? Closure property means if we multiply any two rational numbers, then the result will also be a rational number. That is what is called a closure property. Then we learn commutative property. What is commutative property? If we take any two rational numbers which can be multiplied in any order, the result will be the same. This is what is called a commutative property. Then next, associative property. Associative property means three rational numbers can be multiplied in any order, the result will be the same. That is what is called the associative property. Then we learn multiplicative identity. One is the multiplicative identity. Then finally we learn multiplicative inverse. That means P by Q into Q by P. It is equal to 1. That means Q by P is the multiplicative inverse of P by Q. This is all for today. So in exercise 1, I think you are able to solve the questions given there 1 to 5. You can try to solve question number 1 to 5 given in exercise 1.1.